Next method is about homogeneous differential equation. Now you see I'm writing some functions in two variables. For example, I've written x square plus y square. Then I've written 2x minus 3y. I'm writing some functions in how many variables? Two variables. Then look at here, for example, one more. I'll write y square plus 2xy. Fourth one, let me write x cube plus y cube. Now if you observe these four functions here, in each term power is same. You see here, what's the power of this term? 2. Power of this term 2. Constant has power 0. Power of this term 1. Power of this term 1. Here power is 2. Here the total power of this term is 2. Remember, here 3, here 3. So such functions are called homogeneous functions. Homogeneous functions. Homogeneous functions. Remember, homo means same, you know. Homogeneous functions, we call such functions. 2, 2, 1, 1, 2, 2, 3, 3. Look at this. If I write x cube plus y square. Now you see here power 3, here power 2. So not a homogeneous function. Not a homogeneous function. Homogeneous function. Not a homogeneous function, remember. Fine. Look at one more. Let me write like this. X square plus y square. Here x cube plus y. So here 2, here 2, here 3, here 1. So again, not a homogeneous function. Not a homogeneous function, remember. Homogeneous function means what? Each term should have same power, remember. Each term should have same power, same exponent, same power, same exponent or power. Then it is called homogeneous function. Fine. Now here, if I consider one differential equation like this, differential equation means what? It should involve dy by dx. So if I write dy by dx plus, I'll write x plus y upon 1 minus xy equals to 0. For example, I've written this. Now you see here, if you look at this function, here 1, here 1, here 1, here 1. So this is called homogeneous differential equation. Homogeneous differential equation. Fine. So a differential equation that involving homogeneous functions of the same degree, it is called the homogeneous differential equation. If I write one more here, one more, let me write x cube plus y cube into dy plus, if I write 2x square y plus 3xy square into, let's write dx equals to 0. Now this is also a homogeneous function. You see here degree 3, constant has degree 0, remember. Degree of this term is 2, here 1. So total degree 3 here, total degree also 3. So this is called homogeneous function of differential equation of the homogeneous functions of the same degree, remember. In general, what I'm trying to tell you, this is a differential equation which is homogeneous, right? Fine. Now here, if you look at it, next exercise 9.5, you see there, in that exercise, everywhere you have homogeneous differential equation, just have a look. In each function of two variables, you will find the same degree, remember. Okay, so exercise 9.5 is based on homogeneous differential equation, you will notice. One more thing before I get into that. See, if I have this function, for example, x cube plus y cube upon let me write x cube minus y cube. So what I can do is I can take highest power of x common. So I'll take x cube common. So 1 plus y by x the whole cube upon, here also I'll take x cube common. So 1 minus y by x the whole cube. Right? Now this will get cancelled, but what is this? This is a function of y by x. This is a function of y by x. So every homogeneous function can be expressed in y by x or in x by y form, remember, right? Every homogeneous differential equation can be even in general expressed in this form, remember. Look at this. Suppose I'm just taking this example here. You can find x square common from this. So what I'll get? Y by x the whole cube plus 2 as it is. I'm taking x square common. So here it is y by x. Now you can see that this is a function of what? Y by x. Right? So this can be done, remember. Okay. So even if you look at it, 9.5 exercise, if you just observe exercise 9.5, there you have some questions involving y by x or x by y. Just have a look. You have functions involving y by x or x by y. That means this is about homogeneous differential equation, remember. Okay, so in any question, if y by x or x by y is involved, that means that is about homogeneous differential equation. Fine? Is this clear to you? Now I'll just I'll give you 2 steps. With the help of those 2 steps, you can solve every question of 9.5. Very simple technique, remember. After 2 steps, immediately you have integration, remember. Fine? Okay, so I'll write steps to solve the homogeneous differential equation. Okay, so let me write here. Steps to solve homogeneous differential equation. Homogeneous differential equation. Steps to solve the homogeneous differential equation. So first step is here. Step number 1 is you express the given homogeneous differential equation in dy by dx equals to some function. Fine. Dy by dx equals to function in this form, remember. Dy by dx equals to some expression. Once you express in this form, then next step is, this is a substitution. Put y by x equals to v, small v. This is a substitution because you are going to integrate this. So here we are taking y by x equals to v. So what is y? That is vx. Right? We use normally small v here. Now once you do the substitution, you need to differentiate it. So dy by dx, v as it is, here 1 plus x as it is, and this is dv by dx. So therefore dy by dx equals to v plus x into dv by dx, remember. This is what you need to use. Step number 1, express in this form, dy by dx equals to something. Put y by x equals to v substitution. Therefore after the differentiation you have this. And then after doing this, you use variable separable form, VS form, right? That is the previous method. So you can solve it. This is what you need to do. Clear? What is the first step? Express dy by dx equals to something. Put y by x equals to v substitution. Then this is y equals to vx. And then this is just by differentiation. After using this substitution, use the variable separable form. So immediately you will get the solution of the given differential equation. Now sometimes differential equation may involve x by y, remember. As I told you earlier, either differential equation involve y by x or x by y. So if it involves x by y, you can put then you can put this equals to v substitution. Put x by y equals to v substitution. So therefore x equals to vy. Now in this case we are going to differentiate with respect to y. Remember, here I had differentiated with respect to x. So dx by dy, here product rule, v as it is, derivative of y with respect to y1 plus now y as it is and derivative of v with respect to x, right? And in this case your differential equation should be expressed in this form, dx by dy equals to some expression, remember. Fine, this is what you need to do. And then as I told you, variable separable form. I repeat, sometimes differential equation itself contains x by y. So in that case we put x by y equals to v substitution. Therefore x equals to vy. Now there we were differentiating with respect to x. Here we differentiate with respect to y. Derivative of x with respect to y, dx by dy. V as it is, derivative of y with respect to y1. Y as it is, derivative of v with respect to y, sorry. So dv by dy, I'm sorry here. dv by dy, remember. And here when x by y is involved, then you are not going to express in this form dx, dy by dx form, but you are going to express in this form dx by dy. For example, if I show you, see here, such x by y is involved in question number 10 of the exercise, right? Question number y contains y by x, but in question number 10 x by y is involved. Fine, so you can use this technique in that question. Okay, fine. So now we just go to exercise 9.5 with this technique. Either you put y by x equals to v substitution or x by y equals to v substitution. But here remember, dy by dx form, here dx by dy form. Right? It's very straightforward. You will see all questions are having almost similar procedure. Right. Okay. So here exercise 9.5, just read the question, solve the given differential equation, which are obviously homogeneous differential equation. Your first question, given differential equation is x square plus x into y into dy equals to x square plus y square into dx. Fine. Now what's the first step? Have you noticed that this is a homogeneous differential equation? See here, degree 2, here degree 2, here degree 2, here degree 2. So if you want, just you can write it is a homogeneous differential equation. What is the first step? Get the dy by dx, as I told you. dy by dx equals to something. So this will go down. X square plus xy, and here you have x square plus y square. Fine. Just we have rewritten in which form? Dy by dx equals to something. This is the first step, remember, in every question of exercise 9.5. Okay. Now what is the next step? Put y by x equals to v substitution. That is y equals to vx. Now differentiate it. Differentiating with respect to x. What is derivative of y with respect to x? dy by dx. V being const, we keep as it is, differentiation of x 1. Now x as it is, derivative of v with respect to x, which is dv by dx. We place this value in equation number 1. I'll write by 1 here. By 1. What is dy by dx? This much. So we are going to replace this. That is v plus x into dv by dx. Go to RHS. What is the right hand side? There we are going to put y equals to vx. So x square as it is, this become, instead of y vx, v square x square upon here x square as it is, instead of y you are going to put this. So we get v and xx, that's x square. You can see that x square you can take common and it will get cancelled. And I'll take v on the other side. So x dv by dx equals to take x square common, it will get cancelled. So 1 plus v square upon 1 plus v. Now this is purely about variable v. So I'll take v on the right hand side. We simplify this. Now you can see that this is equation in what? V and x, remember. So 1 plus v square minus v square upon 1 plus v. So this will get cancelled. So therefore x into dv by dx equals to 1 minus v upon 1 plus v. This is just simplification, remember. You did nothing so far. Now, which method? Variable separable form. This is about variable v. So I'll take with dv and I'll take this one on the other side. So the next step here, is therefore 1 plus v upon 1 minus v into dv equals to here 1 upon x dx. You can see that now this is which form? Vs form. Right? With dv you have an expression about variable v. With dx you have expression about x, remember. Okay, now next step is integrate it. So integrating, alright, integrating here. So integral of 1 plus v upon 1 minus v dv equals to integral of 1 by x with respect to x. So now this method is over. Only question comes to what? Integration. How will integrate this? This is linear upon linear form, remember. So normally in such questions, what you can do is you can set this expression over there, or you can just take some substitution also. Choice is yours how to integrate this, remember. So here what I'll do, just to make this coefficient positive, I'll take minus common here. So v plus 1 upon, if I take minus common, v minus 1 dv equals to 1 upon x dx. And I'll take minus 1 on that side. And I'll set this expression over there. So minus 1 plus 2, adding and subtracting 1 upon v minus 1. Right? This is linear upon linear. So normally we set this expression over there. I'll take minus sign on the other side. So minus 1 upon x dx. Now do individual division. This upon this gives us 1. This is 2 upon v minus 1. dv equals to minus 1 upon x dx. Now integrate this. What's the integral of 1? That is v here. 2 being constant as it is. This is log of mod of v minus 1. Equals to minus log of mod of x, and I'll put your log at two places. So instead of c, I'll write the log c as a constant. Okay, so integration is over. Now question is just simplification. I'll take all the terms having log function on one side, v on the other side. So twice log of v minus 1, I'll drop the modulus, plus log of x minus log c equals to minus v. I'll take on the other side. Now this 2, it will go in power here. So v minus 1 the whole square. This addition becomes into and subtraction becomes division. So by c equals to minus v. I'll drop the log function. If I drop the log function, the other side you have exponential function, remember. So it is e raised to minus y by x. Value of, okay, I'll keep right now v here, and then I'll place the value. Now I'll place the value here. So y minus x the whole square upon x square, that will get cancelled with this x. So you are getting cx equals to e raised to minus y by x. And therefore finally here y by x the whole square equals to cx into e raised to minus y by x. This is a required solution, remember, where c is arbitrary constants, is a required solution. Fine. The only important thing is this integration, remember here. Beginning is not important. In the first two steps, you did nothing. What you did, just you got the dy by dx, you placed the substitution, and then you just simplified. What is important, as I keep on telling since beginning, integration. This integration is very important, remember. Right? Sometimes you may have confusion. If I put c here instead of log c, then it will not be wrong, remember. But sometimes you may face the problem of matching backside answer. Right? So don't worry. Sometimes if you take here c, your answer would look totally different, but it's not wrong. So it's not a big issue. Don't worry about it. But here I'm trying in such a way that we get the almost backside answer. So realize, remember. So this is your backside substitution. Y minus x the whole square, c into x is equal to into e raised to minus y by x, required solution of the given differential equation. This is the general solution, remember. So that's what you have to do in every question now, remember. Second question, y dash equals to this. So y dash means dy by dx equals to x plus y upon x. So it is already in dy by dx equals to some expression form. You can write, if you want, individual division 1 plus y by x. Fine. So what is your next step now? Put y by x equals to v substitution. As I told you, put y by x equals to v substitution. Therefore y equals to vx. Now differentiation, remember. What's the derivative of y with respect to x? Dy by dx. V being constant, v as it is, differentiation of x 1, x as it is, dv by dx, remember. Product rule on the right hand side. We call this as 1. So by 1, left hand side, dy by dx, we place this much. What is that? V plus x into dv by dx. Go to RHS. Here you have 1 plus y by x, which was v here. So simply v. So v will get cancelled. You are getting x into dv by dx equals to 1. Now next step. What is the next step? Solve further by which method? You know, variable separable form. Now this much you need to take on the right hand side. So here dv equals to 1 upon x dx, remember. This is which form? This is nothing but vs form, variable separable form. This is simply vs form. Okay, so now we integrate it. So integrating. So integral of 1 with respect to v equals to integral of 1 upon x, remember. What's the integral of 1 with respect to v? It is v. What is this? Log of mod of x plus constant c. Now we need to put the value of y because that was a substitution. So what's the value of v? Which is y by x equals to log of mod of x plus c. And now take x on the other side. So y equals to x into log of mod of x plus cx, which is required solution. This is, in fact, you know, this is a general solution because there is arbitrary constant involved in this. So here integration was little bit easier, remember, but steps are same, remember. Okay. Next question. Let's go to question number 3. Third question. Question number 3. X minus y into dy minus x plus y into dx equals to 0. So by just writing the equation, you must realize that this is a homogeneous differential equation. 1, 1, 1, 1. Power of each term. Here 1, here 1, here 1, here 1. So this is a homogeneous differential equation, remember. That you need to observe. Now once it is a homogeneous differential equation, you can express in which form? dy by dx equals to something, right? Dy by dx equals to some expression. Okay, so I'll take this one over there. X minus y into dy equals to x plus y into dx. Therefore, dy by dx equals to here x plus y upon this will go down, which is x minus y. Just do the cross multiplication, you will get the above step. Fine. Next step, substitution. Once you express in this form, always next step is put y by x equals to v substitution. Therefore, y equals to vx. Therefore, now after differentiation, you will get this dy by dx, v as it is, here 1 plus x into dv by dx. So using this, by 1 we'll get, so I'll write by 1. What is left hand side? That is this one, v plus x into dv by dx. Left hand side is this much, you know. What about right hand side here? X as it is. Y you are going to place vx upon your x as it is. Y you are going to place what? Vx. Therefore, v plus x into dv by dx equals to 1 plus v upon 1 minus v. X will get cancelled, you know, as we did earlier. Take x common, take x common. Take v on the other side. X dv by dx equals to 1 plus v upon 1 minus v minus v. Now simplify this. So this one as it is, x dv by dx equals to 1 plus v, here minus v and plus v squared upon 1 minus v. Right, if you just multiply, this is minus v and minus will be plus v squared. So this will get cancelled. So here we are getting 1 plus v squared upon 1 minus v. Now you can see that this is purely in v and x. So next step is variable separable form. So this will take over here. 1 minus v upon 1 plus v squared into dv equals to 1 upon x dx. Right. This is nothing but which form? Vs form. Variable separable form. Which form? Variable separable form, remember. In homogeneous differential equation, always one side will be 1 upon x dx. On the other side, you have dv into an expression involving variable v, remember. Now, the question again, integration. Right? How to integrate this? So let's see that. So here, in the next step, we have integral of 1 upon 1 minus v upon 1 plus v square dv equals to integral of 1 upon x dx. Okay, this is linear upon quadratic, so you can set the derivative. Derivative will be 2v, so I can write individual division minus, here I need 2v, so multiplying with 2 and dividing by 2 equals to integral of, 1 by x. I hope this is clear to you. This is linear upon quadratic. These upon this. First what I did, individual division, and then just setting the derivative. What is this? This is very well known standard form. This is nothing but the tan inverse v. What's the derivative of tan inverse v? 1 upon 1 plus v square minus 1 upon 2 as it is. What is this? This is f dash upon f form. So log of mod of 1 plus v square. Fine. And here, if you want, you can write log c, or you can write just c equals to, here obviously first is log of mod of x plus, if you want, you can write log c or just c as a constant, remember. Okay, so integration is over. Now I'll place the value of v. So tan inverse here y by x, or I'll take this one over there. So this is nothing but here 1 upon 2 log of x squared plus y squared by x squared, because v is y by x, plus log x plus c. So this is tan inverse y by x equals to, I'll take 2 as LCM here, or you can just take 1 by 2 common here, that is same as just taking LCM. Log of x square plus y square by x square plus 2 times log of here x plus 2c. So therefore tan inverse y by x equals to 1 upon 2. Now here you can take this 2 in power and you can multiply this 2. So log of x square plus y square by x square into x square, taking log common, plus 2c as it is, remember. And therefore tan inverse, finally this is the last step, 1 upon 2 x square will get cancelled. So this is log of x square plus y square, this will get cancelled, and again this 2 will get cancelled, so we'll get the plus. This is a required solution. Fine. Now sometimes what happens, there is of course a little confusion at this step. Can't we write here log c instead of c? Yes, so you could have done like this also. This is also correct, remember, don't worry. So I would have written like this, tan inverse v minus half log of 1 plus v square equals to here log x plus, instead of c I can write log c also. Then I'll take this term over there, tan inverse v equals to half, if I take common, this is log of 1 plus v square plus twice here log x plus twice log c. Now I'll do two things. I'll put the value of v that you need to put, and I'll use the property of the log function on the right hand side. So tan inverse y by x equals to 1 upon 2 here log of, I'm taking log common, y by x, so here y square plus x square by x square. This 2 will go in power, so this is x square, and this 2 will go in power, c square. And once you take log outside, this addition becomes into, remember, this will get cancelled. So you will get the tan inverse y by x equals to half log of x square plus y square into c square. That way also you would have written, which is almost same as this. If you think for a while, you will realize this is just same as this, remember, right? So whether you write here c or log c, both are almost same, remember, so don't worry about it. The important one is this integration, remember, how to handle the integration, that's the most important point. So this is the required solution here. Whether you write this as I told you, or you write in this form, taking log c, or here just taking c, both are almost same. Fine. I know questions are a little bit lengthy as far as integration concerned, but not difficult. Nothing you have to think here, right? It goes very smoothly. Fine. Next question. Fourth question. Just observe, you will see that it is a homogeneous differential equation. Here 2, constant has power equals to 0, but here 1, so this term has total power equals to 2. So homogeneous differential equation. We are going to express in which form? Dy by dx equals to something. So I'll write dx equals to minus 2xy into dy. and therefore dy by dx equals to minus, dy will go here, coefficient of this, so this will go down, and this is x square minus y square. Fine. In which form I've expressed? You know, as I told you, express in dy by dx equals to something form. Fine. Okay. Now you can do one thing, you can just keep 2 over here, because here it will be in the numerator, and you can do individual division, because here you have 2 terms, here you have just 1 term. So your minus, here you will get the x by y, minus here, what about this? 1 term will get cancelled of y, so you have y by x, but this will be plus. Now call this as 1, and you know, put y by x equals to v substitution now. So it implies y equals to vx. Differentiation. So dy by dx equals to v plus x into dv by dx. What I did, you know, I've used the product rule. Differentiation of y with respect to x dy by dx, v being v as it is, differentiation of x with respect to x 1, x as it is, derivative of v with respect to x dv by dx. So if you use this by 1, we get here, what we'll get, 2 times dy by dx, that is this much, v plus x into dv by dx, that is equals to, what's that, reciprocal of this, minus 1 by v, and this is just v. Now we take all the terms having variable v on the other side. So 2 into x into dv by dx equals to minus 1 upon v. This is 2v. So on the other side it will be here minus 2v, and from this you will get just minus v. Fine. So here you have 2x into dv by dx equals to, take minus common, 1 plus v square upon v. Now what's the next step? You know, variable separable form. That's your next step. So I'll take this expression over here. 2 is already there. V upon 1 plus v square into dv. Your minus sign is already there. X will go down, 1 upon x dx. This is nothing but which form? Vs form. Now I leave it for you. Just do the integration and see. Right? You know integration of this one, not difficulty. F dash upon f form, log of mod of 1 plus v square minus log of mod of x. You can put the logs here as a constant. Clear? Up to this it is important. Now it's just question of integration. In the fifth question, x squared into dy by dx equals to this 2 here, sorry, there is a y squared here, y squared 2. So this is a homogeneous differential equation. That's the first thing you need to observe. Okay, then what's the first step? Get dy by dx equals to some expression. So dividing by x square, so x squared minus 2y square plus xy upon x squared. If you want, you can do individual division, or you can put directly substitution. Choice is yours, remember. You can do, if you want, individual division. X squared by x square 1, 2 times y by x the whole square, plus here 1x will get cancelled, so this is y by x. Fine. Now substitution. You could have dropped this step, remember. Directly also you could have taken the substitution. Put y by x equals to v substitution. That is y equals to vx. Now differentiation. dy by dx. On the right hand side, product rule. V as it is, here 1, plus x as it is. Differentiation of v with respect to x, that is dv by dx. Call this as 1 and you write by 1. So by 1 here, what is left hand side? It is this much, that is v plus x into dv by dx. Go to right hand side, this one, 1 as it is minus 2 times, this is nothing but the v square, plus what is this v. Fine. Now you know here you take this v on the right hand side, so v will get cancelled. So we are getting x into dv by dx equals to 1 minus 2v square. So you are left with now v and x. Now what's the next step? You know, variable separable form. So 1 upon 1 minus 2v square will come down into dv. On the right hand side, x will go down, 1 upon x, dx will be over here. This is which form? Variable separable form, remember. Now integration. You know, integration is not difficult here, remember. Left hand side, you know, it is one of the standard formula. Left hand side is not a big task, remember. This can be integrated very easily. Just I'll show you. 1 upon 1 minus this, you can write root 2v the whole square. This is 1 square equals to over here integral of 1 upon x. Now you know this is a square minus x square, so it is 1 upon 2a. A is 1 here, log of mod of, you know here, log of mod of, here you have constant first, so a plus x, that is root 2v upon 1 minus root 2v. If you remember this very well-known formula, but here the coefficient of v is root 2. So, and you had considered these as x. So when you integrate it, you need to write upon the coefficient of x, which is root 2 here. That much is important here. Log of mod of x plus, I'll write c. Now only thing is you just put value of v, y by x. So that's your required solution. This you need to put. I'm not placing here. Put y equals to v equals to y by x and simplify. So I'll get the backside answer. Fine? Clear?